Today, we're diving into something you probably use every single day, your headphones. We're going to pull back the curtain and look at the amazing tech that takes a simple electrical signal and turns it into the music you absolutely love. I mean, seriously, have you ever stopped to think about it? How can these tiny little things that fit in your pocket create a sound that feels like a full orchestra or a bass line that you can feel in your chest? It really does feel like a bit of magic. But it's not magic. It's just some really, really cool engineering. You know, when you boil it all down, every single pair of headphones on the planet, from the cheapest earbuds to the fanciest studio monitors, does one basic thing. It takes an electrical signal from your phone or your computer and turns it into physical vibrations. That's it. Those vibrations are what your ears pick up and what your brain understands as sound. So, how does that happen? How do you turn electricity into, well, a vibration? It all comes down to a critical little component, and its name is the transducer. Yeah, a transducer. It sounds super technical, but the idea is simple. Think of it like a translator. It takes one form of energy, in this case electricity, and it converts it into a totally different form. Mechanical energy, which is just a fancy way of saying vibration or sound. It's the bridge that makes everything you hear possible. Now, in the world of headphones, we don't usually say transducer. We have a cooler name for it, the driver. And let me tell you, the driver is the heart and soul of your headphones. It is, without a doubt, the most important part when it comes to how good they're going to sound. So let's break down how the most common type works. Okay, so the first piece of the puzzle is a permanent magnet. This thing is just sitting there, creating a steady, stable magnetic field. It's kind of like the anchor for the whole operation. All right, next up, we send the electrical current from your music through a really fine coil of wire. We call this the voice coil. When that electricity flows through, it instantly turns the coil into a tiny electromagnet, and its magnetic field zaps on and off and changes like crazy, perfectly in time with the music. And finally, the part that actually makes the noise. Attached right to that voice coil is a super thin, lightweight cone or dome called a diaphragm. When the voice coil moves, the diaphragm has to move with it, pushing and pulling the air around it. And that movement creates the sound waves that travel into your ear. So, putting it all together, you can see how this little dance works. The electrical signal comes in, it zaps the voice coil, making it jump back and forth inside the permanent magnet's field. And because the diaphragm is attached, well, it gets pulled and pushed along for the ride. That vibration is what creates sound. That's the whole magic trick right there. So that's the basic blueprint for the most common kind of driver. But, engineers, they can never leave well enough alone. So over the years, that one simple idea has blossomed into a bunch of different designs, and each one has its own totally unique character and sound. The two big players you're going to run into most often are dynamic drivers, which is the type we just talked about, and this other, more intricate design called a balanced armature, or BA for short. They get that cool name because the moving part is perfectly balanced between two magnets, which lets it move with incredible speed and precision. And this chart really lays out the trade-offs, right? Dynamic drivers, they're awesome. They give you this warm, natural sound with really punchy, strong bass that makes them perfect for stuff like pop, rock, or electronic music. Balanced armatures, on the other hand, are all about clarity and detail. They can be a little weak on the bass, but if you listen to classical or really want to hear every little nuance in a singer's voice, that precision is just unbeatable. So, what if you want that big, punchy bass and all that crystal clear detail? Well, that's where hybrid drivers come in. The idea is brilliant. Just use both. You use a big dynamic driver to handle the low-end bass, and then you use one or more of those super detailed BA drivers for the mids and highs. But here's the catch. It's a real engineering challenge to get these two totally different technologies to blend together seamlessly into one cohesive sound. All right, let's talk about the numbers for a second. You've probably seen specs like ohms and dB on a headphone box, and maybe your eyes just kind of glazed over. Don't worry, we're going to quickly decode what they actually mean for you. First up is impedance, and it's measured in ohms. Honestly, the easiest way to think about it is like plumbing. It's basically the electrical resistance. A low impedance is like a really wide pipe. Water flows through super easily. High impedance is like a narrow pipe. You need a lot more pressure to get the same amount of water through. And here is why that actually matters to you. Your smartphone, well, it has a pretty weak pump, so it needs that wide pipe. Low impedance headphones, usually around 20 to 40 ohms. High-impedance headphones, the narrow pipes, need a much more powerful source to sound good, which is why they're often used with dedicated headphone amplifiers in a studio. Next up, sensitivity, measured in decibels, or dB. This one's all about efficiency. It basically tells you how loud the headphones will get with a certain amount of power. Think of it like fuel efficiency in a car. A more sensitive headphone gives you more volume for the same amount of power. And just to put that number into perspective, 110 decibels is loud. We're talking as loud as a rock concert. It's also right around the average human pain threshold. So while your headphones might be capable of getting that loud, you really don't want to listen at that volume for very long if you value your hearing. So we've gone through the physics, the parts, the nerdy specs, but how do you actually use all this information to find the perfect headphones for you? Well, it's actually a pretty simple three-step process. First, just think about the music you love. Are you a bass head who listens to EDM, or do you crave every last detail in an acoustic guitar track? Second, match that music to a driver type. Go for a dynamic driver for that bass and warmth, a balanced armature for that amazing clarity, or a hybrid if you want a little of everything. And last, just do a quick check to make sure the impedance is a good match for whatever you're plugging them into. So there you have it. The next time you put on your favorite headphones, you'll know exactly what's happening inside that tiny shell to create the sound you're hearing. So the real question is, now that you know the secrets, are you going to hear your music a little differently? Thanks for tuning in.